All right, this is the review for circles 9, 3, and 10, 1. So 9, 3 was all about the equation of the circle, which is x minus h squared plus y minus k squared equals r squared. Your center is hk, so hk. And then your radius is r. So whatever r squared is, you have to take the square root of it to get r by itself. All right, so the first one, x minus h. So this is going to be 1, 3. Right? Remember, a lot of you guys think of switching the signs. It's not really the best way to think about it. But if you do that, you're gonna get it right. So 1, 3. There's my center. Okay, and then my radius is 2, right? So r squared is 4. That means my radius is 2. So I'm gonna go to my center, I'm gonna go up 2. I'm gonna go to my center, I'm gonna go down 2. I'm gonna go to the center, I'm gonna go right 2. I'm gonna go to the center, I'm gonna go left 2, and I'm gonna fill in the circle as best as I can. It was good right up until the end there. There you go, there's my circle. So all the points on the circle are 2 units away from the center, and the center is 1, 3. All right, on the next one, the center is going to be 4, 2. So 4, 2 is right here, right? And then r squared is 9, so the radius is going to be 3. So I'm going to go up 3, back to the center, down 3, right 3, left 3. And there's the circle as best I can draw it. All right, and the next one, notice how the x and the y's are in different orders, so it's just not in standard form. That's okay. So if you're looking at the x, remember x plus 1 is the same as x minus -1, right? So if you're looking at your equation, the h here is going to be -1 because you can rewrite x plus 1 as x minus -1. Okay. And then y, same thing. You can rewrite this as y minus -3. So you have y minus k, and your k is going to be -3. So we have -1, -3 is our center. And then our radius here is going to be 4. So 1, 2, 3, 4 above, 4 below, 4 to the right, 4 to the left. And there's our circle as best as we can draw it. All right, number 2 should be even easier because they don't want you to graph it. They just want you to find the radius and the center. So the center of this one should be -2, 5. Right? Minus -2 and then -5. And then your radius is the square root of 36, which is 6. All right, this one, x squared is just like x minus 0 squared. So we have 0 and then +9 for my center. And then my radius is going to be square root of 18, which is, so this could be split into 9 times 2 is going to be 3 square root of 2 is the simplified answer. Okay, our center here, again, they flip the x and the y's. So it should be -7, -1. You got to be careful of that. And then my center should be square root of 24. And if we reduce that, 6 times 4, so 4 times 6, square root of 4 is 2. So you have 2 square root of 6 is the simplified form of square root of 24. All right, number 3, they want you to write the equation of the circle. Okay, so our center here is 1, 2, 3, 4, 5, 1, 2, 3, 4. So it's -5, +4. right? And then your radius is 1, 2, 3, 4, 5. So r equals 5. So when we write this out, it's going to be x minus -5 becomes x plus 5 plus y minus 4 squared equals 5 squared, which is 25. All right, the next one, your center is right here. Right, if you look at the two diameters, this is where they meet. This is 3, 1, and your radius here is 4. You can just count 1, 2, 3, 4. So we're going to have x minus 3 squared plus y minus 1 squared equals 16. Number 4, we want to start number 4 and 5 out by writing the equation of the circle, and then we're going to substitute in the coordinate, the point 3.4, 1.2, into the equation and see if it works. All right, so my equation should be x minus 1 squared plus y plus 2 squared, and then r squared is 16. Okay, and then we're going to substitute in for x and y. So I'm going to do 3.4 minus 1 plus 1.2 plus 2 squared. When I put that all in my calculator, I'm going to get 16 equals 16. So that means yes, this point is on the circle. All right, same thing for this one. Let's write the equation first. This is going to be x plus 1 squared plus y minus 0 squared is just y squared. And then equals r squared, which is 9, right? R is 3, so r squared is 9. We're going to substitute in this point here. So we're going to do negative 3.8 plus 1 squared plus 1 squared equals 9. And when I put that in my calculator, I get 8.84 equals 9. Okay, and that's not true. So we're going to say, no, this point does not lie on the circle. It does not. It's going to be inside of the circle. All right. If it was bigger than 9, then it would be outside of the circle. All right. Now we need to complete the square. So first thing I'm going to do is line up my x's. X squared minus 4x plus y squared plus 10y. And I'm going to move the 7 to the other side. I'm going to add 7 to both sides. So you get equal 7 on the right side. All right, next thing I'm going to do is I'm going to do, right, if we remember, standard form of a quadratic is ax squared plus bx plus c, right? We're looking for b divided by 2 and then squared. Okay, so for x, the b is going to be -4. So I'm going to do -4 divided by 2, which is -2, and then I'm going to square it. -2 squared is 4. Okay, plus y squared plus 10y. And then again, the b here for the y's is 10. So 10 divided by 2 is 5, and 5 squared is 25 equals 7. Okay, if I add 4 to the left, I need to add it to the right. If I add 25 to the left, I need to add it to the right to balance my equation. Okay, and then I can factor. So for the x's, I need two numbers that multiply to 4 and add to -4. That should be -2 and -2, right? Whatever b divided by 2 is. So -4 divided by 2 is -2. So my two factors are x minus 2 and x minus 2, which means I have x minus 2 squared plus, Okay, we're factoring these. So we need two numbers that multiply to 25, add to positive 10, which should be 5 and 5. So we're going to have y plus 5 and y plus 5, which we're going to simplify to y plus 5 squared. And then that equals 7 plus 4 is 11. 11 plus 25 is 36, which means our center is 2, -5. And our radius is 6. All right, next one's the same thing. So we'll line up our x's. Looks like they're already lined up. The only thing here to do is move the 18 to the other side. Okay, and then our b's here are going to be -2 and 12. So I'm going to do x minus 2x. -2 divided by 2 is -1. -1 squared is +1. Okay, y squared plus 12y. Well, 12 divided by 2 is 6. 6 squared is 36. So I'm going to add 36. All right, and then if we added it to one side, we got to add it to the other. So I'm going to end up with, sorry, this is x squared, right? So then I factor, I'm going to get x minus 1 squared plus y plus 6 squared. And that's going to be all equal to 19. So when I write my center, I'm going to have 1, -6. My radius is going to be square root of 19. All right, if you're wondering where we got this from, we factored, right? So you got to have something that multiplies to 1 and adds to -2. That should be -1 times -1. And then for the y's, it should be 36 and 12, which is 6 and 6. All right, and that's it for 9-3. The rest of this is going to be 10-1. Okay, find the radius, diameter, area, and circumference of the circle. Okay, well, the radius here is just 16.1 centimeters. Right, the diameter is twice the radius, so 16.1 times 2 is going to give us 32.2 centimeters. Right, we know area is pi r squared, and we know circumference is 2 pi r. So all we're going to do is take that radius, and we're going to substitute it in for r in our two formulas. So when I do that, for circumference, 2 times pi times 16.1, I'm going to get 32.2 pi. Right, and then centimeters, right? Pi centimeters, right? Then for area, I'm going to do pi times 16.1 squared, which gave me 259.2 pi centimeters squared. I could just put that in there myself, right? Centimeters squared. Okay. If you multiply the pi in there and get a decimal answer that's not exact, that's okay. But I'm going to leave it in terms of pi. All right, the next one, the diameter is 8.5, right? That's the distance across the whole circle, 8.5 inches, which means the radius is half of that, which is going to be 4.25 inches. Okay. And then we're just plugging into the circumference formula. That's 2 times pi times 4.25, which should be 8.5 pi inches. And then area, pi times 4.25 squared. And I got 18.0625 pi. And that should be inches squared. Inches squared. Okay, if you multiply the pi in there and get a decimal, that's fine too. I just left the pi out. All right. Let's look at number 8. So find the circumference of each circle. So we have the area. We know area is pi r squared. We know the area here for this one is 64 pi. So I'm going to substitute it in for A. Okay, we can divide both sides by pi. That gives us 64 equals r squared. And then you take the square root of both sides. That gives us 8. It really gives us plus or minus 8, but you're not going to have a minus 8 radius here. Great, and then we want to plug into the circumference formula. So 2 pi r. So that's going to be circumference equals 2 times pi times 8, which is going to give us 16 pi miles squared. Okay, we're going to do the same thing for the next one. So 16 pi is going to equal pi r squared, right? Because it's the area, so it equals pi r squared. We divide the pi's on both sides. You take the square root of both sides, we get 4 equals r. And now we're going to plug that in or substitute that into the circumference formula. 2 times pi times 4, which gives me 8 pi, and the units on that should be inches. So it should not be miles squared, it should just be miles. And this should just be inches. Circumference is a one-dimensional length. It should not be squared. All right, number 9, find the area. So these ones we are going to want to square. So again, they're going to give us the circumference. So C equals 2 pi r. So we get 6 pi equals 2 pi r. We can cancel out the pi's, and then 6 divided by 2 is going to give me a radius of 3. And then we can find the area by doing pi r squared. So in this case, it's going to be area equals pi times 3 squared, which is going to give me 9 pi yards squared. 9 pi yards squared. All right, last one here, circumference is 22 pi. So I'm going to do 22 pi equals 2 pi r. Divided by pi, and then 22 divided by 2 is going to give me a radius of 11. And then when I plug that in the area formula, I'm going to get pi times 11 squared, which is going to be 121 pi inches squared, which, I don't know, should be about 365 or so inches squared. All right, last one on the front here. It says find the radius of a circle so that its area and circumference has the same value. So we want to find r when a equals c, right? When the area equals the circumference. So we're looking for r when pi r squared equals 2 pi r. Okay, I can divide both sides by pi. I get r squared equals 2r. I can divide both sides by r. Right? And I get r equals 2. So if you substitute in 2 into the circumference formula, 2 times pi times 2 is 4 pi. If I substitute it in for the area, that's pi times 2 squared, which is also 4 pi. The difference would be the units. One would be units, the others would be units squared. All right, on the back, find the measure of the arc. So again, you're looking for semicircles. So I to L is going to form a semicircle, so it should add up to 180. 180 minus 75 is 105. Right, and then again, 180 minus 105 is going to be 75. And then these three should add up to 180 as well. So 180 minus 75 minus 65 is going to give me 40. Okay, and now the arc that we're looking for, LIK, is right here. So we can either do 360 minus 75, or we can add up 105, 75, 65, and 40. And when you add those all up, you should get 285 degrees for the measure of arc LIK. Okay, FBD. So the measure of the central angle is equal to the measure of its intercepted arc. So we have a half circle here. 180 minus 113 is going to give me 67. And then same thing here, 67. Okay, and then these three arcs should add up to 180. So 180 minus 67 minus 53 should give me 60. All right, and now we can solve for our arc measure. We're looking for FBD. So it's going to be 113 plus 67 plus 53, which should be 233 degrees. Right, it's 120 plus 113, yep, 233 degrees. All right, 11. So arc length equals x over 360 times 2 pi r. And sector area equals x over 360 times pi r squared. Okay, so this should be 30 over 360 times 2 pi times 5. Well, this one is sector area equals 30 over 360 times pi times the radius, which is 5 squared. All right, then you can plug those all in the calculator. I got 5 over 6 pi inches. You know, if you put the pi in there, I think you're supposed to get 2.6 inches. Just fine. Okay, and then for sector area, I got 25 over 12 pi units. Oh, it's inches. Inches squared. Inches squared. Right? Or if you put the pi in there and rounded, I got 6.54. Or just 6.5 inches squared. All right, wonderful. Okay, number 12. A circle has an arc whose measure is 80 degrees and whose length is 88 pi. What is the diameter of the circle? So I know I need to use arc length here because they're giving me the arc length. So L equals x over 360 times 2 pi r. So I'm going to substitute in 88 pi for L. The arc measure is 80. So I'm going to do 80 over 360 times 2 times pi times r. R is what we're solving for because the diameter equals 2 times the radius. Okay, I can start by dividing both sides by pi and then multiplying both sides by 360. We want to get rid of the fraction. Okay, 360 times 88 is going to give me 31,680. And that's going to be 80 equal to 80 times 2 times r. I'm missing a letter here. 6,080. There we go. So then it's 31,680 equals 160 r. And then you divide both sides by 160. And I get my radius is 198 units. Equals r. Okay, and then to get our answer, we have to double that. So our diameter is going to be 2 times 198 This is going to give us 396 units. All right, 13, find the measure of the central angle. If its length arc of an arc, if its length is 14 pi. So we're using arc length again, because that's what they're giving us. So x over 360 times 2 pi r. So I'm going to do 14 pi equals x over 360 times 2 times pi times 18. The first thing I'm going to do is cancel out my pi's. I'm going to divide them by each side by pi. Right, and then I'm going to multiply both sides by 360. So 14 times 360 gives me 5,040. And that should be equal to 36x. We're getting 36 because we're doing 2 times 18. Okay. So we multiplied both sides by 360. 360. There we go. Now we can divide both sides by 36. And when we do that, we get 140 degrees equals x. Yep. All right, 14. So this time we're using sector area because they're telling us the sector area is 9 pi. So I'm going to do sector area equals x over 360 times pi r squared. I'm going to substitute in 9 pi for my sector area. I'm going to substitute in 90 for my angle measure. I'm going to multiply by pi times r squared. Again, first thing you want to do is divide by pi. Then we can multiply both sides by 360 to get rid of the fraction. So 360 times 9 should be 3,240 equals 90 r squared. We can divide both sides by 90, you get 36 equals r squared. And then you got to take the square root of both sides, and you get r equals 6 units. All right, that's 14. Now we're on to 15. So this one we're finding the measure of the central angle of a sector if its area is 5 pi. So we have the sector area here. So we're going to do 5 pi equals x over 360 times pi times 6 squared. All right, and we can divide both sides by pi. We can multiply both sides by 360. It's going to give me 1,800 equals 36x. And again, we're getting 36 because 6 times 6 gives us 36. 6 squared is 36. And then I could divide both sides by 36. And I got 50 degrees for my answer. Measure of the central angle is 50 degrees. All right, we got a couple more here, 2 more. Okay, the next one, find the area of the shaded region. So we want to find the area of that blue region. So what we're going to have to do is find the area of all of this sector. Okay, so sector area is going to equal 90 over 360 times pi times the radius, which is 3 squared. Okay. If I put that in my calculator, I'm going to get 9 over 4 pi. Centimeters squared. Okay, but we don't want the whole area. We don't want the area of that whole section. We just want the area of the triangle. So area for the I'm sorry, we just want the area of the shaded region. So we need to subtract the area of the triangle. All right, so let's find the area of the triangle is 1/2 base times height. Since this radius is 3 centimeters, all the radiuses on the circle are 3 centimeters. So I'm going to do, just because they're not drawn doesn't mean that the distance isn't 3. 1/2 3 times 3, which is going to give us 9/2 or 4.5. So the area of the triangle is equal to 4.5 centimeters squared. All right, so then to find just the area of the shaded region, we have to take 9/4 pi. And we need to subtract 4.5. And that's going to give us about approximately 2.6 centimeters squared. All right, last one here. Let me draw a box for my horse. Okay, it's 10 by 25, so 10 feet, 25 feet. All right, if it's tethered, let's say to this corner, okay, it's gonna go 30 this way, so maybe right here. Gonna go 30 this way, so maybe right here. And then you can imagine that half circle. Not the best circle in the world, but there's half of us. I'm sorry, 3/4 of a circle. Right? So that's 3/4 times pi. And then your radius is 30 squared. All right, we're gonna have another quarter circle here. So the rope is 30 feet long. 30 minus 10 is gonna give us 20 feet. So we have 20 feet of extra rope. 20 should probably be about right here. Okay, so the radius of this one is 20. So it's a quarter circle. So 1/4 times pi times 20 squared. And then we got one more little part to add here. 1/4 of a circle right here. So this is 5 feet. The length of the rope is 30. So if the barn is 25 feet long there's 5 extra feet that can go around. Should go probably to the middle of the barn. There we go. So that is pi times 5 squared. All right, and then I can add them all together. And when I do that, I got 2,454.5 feet squared. All right, and that's it for the review for circles.